Chapter 6, Section 5, Theorems about roots of polynomial equations. Okay, what we're going to learn in this lesson, we're going to zoom in a little bit, is to solve equations using the rational root theorem, and we're also going to use the irrational root theorem and the imaginary root theorem. All right, so we learned a lot of new words. Rational root theorem, conjugates, irrational root theorem, complex conjugates, and imaginary root theorem. Okay, so let's just jump right in. All right, basically, here's what you need to know. For any polynomial you're given, if rational roots exist, okay, if a rational root exists, in this example, here are the roots. -2, -3, and 4 are the roots. What do we notice? The product of those three numbers is 24. Notice all the roots are factors of the constant. So in general, if the coefficients in a polynomial equation are integers, then any integer root of the equation is a factor of the constant term. So if you look at this original one, the constant is 24. So we know all the factors of 24 could be possible roots. A similar pattern exists to rational roots. Consider the equivalent equation of this. 24x cubed minus 22x squared minus 5x plus 6 equals 0. All right, it factors to this, x plus 1/2, x minus 2/3, x minus 3/4, which have roots of -1/2, 2/3, and 3/4. The numerators of these roots, 1, 2, and 3, are all factors of the constant. And the denominators, 2, 3, and 4, are all factors of the leading coefficient. Both the constant term and the leading coefficient of a polynomial can play a key role in identifying the rational roots. Okay, this role is expressed as a rational root theorem. And on this sheet, this slide, you can use the rational root theorem to find any rational root of a polynomial. Okay, so let's just jump into it. Find the rational root of this equation. So I'm going to rewrite it over here. X cubed plus x squared minus 3x minus 3 equals 0. So step 1. Okay, what are the factors of the constant? Well, it's -3, so the factors would be plus or minus 1, plus or minus 3. The leading coefficient, it's 1, so its factors are plus or minus 1. So let's list all possible factors. Okay, let's list all possible, let's list all possible real or rational factors. So it's just going to be -1, 1, -3, and 3. Because remember, it's the possible rational roots are going to be the constant over the leading coefficient. So we got -1, 1, -3, and 3. So we can just plug these into the original equation if you want, all right, and solve for x every time. Or what I'm going to use is I'm going to use synthetic division. So looking at the equation synthetically, the coefficients are 1, 1, -3, -3. So what I'm going to do is I'm going to synthetically divide by each one of these. And remember, the one that has a remainder of 0 is a root. So let's try -1 first. Remember, in synthetic division, you drop the first term, multiply it by the root. So -1 times 1 is -1. Sum those, you get 0. 0 times -1 is 0. So drop your -3. -1 times -3 is 3. So you get 0. So -1 is a root. Okay. Let's try 1. So again, just dropping down the coefficients. Drop the first one. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. -3 plus 2 is -1. -1 times 1 is -1. So 1 is not. And then we can go through and do all of them, which we will. All right, so here we go. Let's do negative 3. And again, 1, 1, negative 3, negative 3. Drop the first one. 3 times, negative 3 times 1 is negative 3. You sum those together, you get negative 2. Negative 2 times negative 3 is 6. 6 plus negative 3 is negative 3. Negative 3 times negative 3 is 9. So negative 3 is not. And then right now, let's just talk about something we know. Okay? We know this is a third degree polynomial. So that means there's going to be 3 answers, 3 roots. All right? We know if we have rational roots, we can only have 1 or 3. If we have irrational roots, we can either have 0 or 2. Remember, they have to have multiples of 2. So we know right now there's only one real root. There's only one rational root, negative 1. But we'll go ahead and just do negative 3 or positive 3 just so we can see it. Okay. So I got 1, 1, negative 3, negative 3. Drop the first one, 1. 1 times 3 is 3. Add those together, 4. Multiplies that, you get positive 12. You get 9, 27. Again, that's not going to work. So negative 1 is the only root. And again, we learned before break, we learned that, again, a third degree polynomial has 3 roots. Okay? So you can have either 1 or 3 rational roots and 0 or 2 irrational roots or imaginary roots. Okay. So negative 1 is the root. Good job. Here we go. Next slide. Find the rational root. Okay. I already did some work. So the factors of the coefficient are plus or minus 1, plus or minus 8, plus or minus 2, plus or minus 4. The leading coefficient's 1. So we can list all of our possible factors. So it's going to be 1, 2, 4, 8, and then negative 1, negative 2, negative 4, negative 8. So we know right now we could have 3 rational roots or 1 rational root. If we have 3 rational roots, that means we have 0 irrational. If we have 1 rational root, it means we have 2 irrational. Okay? So let's look at this. Again, I'm going to use synthetic division. You can just plug and chug if you want. Okay, so looking at the original equation, the coefficients are 1, negative 4, negative 2, and 8. Okay, I'm going to start with 1. Drop the first coefficient. 1 times 1 is 1. Negative 4 plus 1 is negative 3. 1 times negative 3 is negative 3. You sum those, you get negative 5. Negative 5, you get 3. So 1 does not work. Let's mark 1 out. Okay. So let's go to 2. So since 1 doesn't work, we can eliminate C. So let's go to 2. Okay, again, my coefficients are 1, negative 4, negative 2, 8. Drop the first one, 1. 1 times 2 is 2. Negative 4 plus 2 is negative 2. Negative 2 times 4 is negative 4. Negative 4 plus negative 2 is negative 6. Negative 12, it's negative 4. So 2 does not work. So we got to try 4 and 8 now. So let's try 4. 1, negative 4, negative 2, 8. Drop the first one, 4. 0, 0, negative 2. Negative 2 times 4 is negative 8. So that is 0. So 4 is a root. Since it's multiple choice, I don't need to check any negatives or anything like that. The answer is 4. Okay. And we can, again, I'll show you later how to solve it completely. All right, so find the roots. Find the roots of 2x cubed minus x squared plus 2x minus 1. So let's find all the possible factors first. So all the factors, the leading coefficient is 2. So all the factors are plus or minus 1, plus or minus 2. The constant is negative 1, so all the factors are plus or minus 1. So all the factors are all the possible constants over leading coefficients, so that could be 1, negative 1, 1/2, and negative 1/2. Okay, so again, I'm going to do synthetic division. So the coefficients are 2, negative 1, 2, negative 1. So let's do 1 first. So I'm going to do 1. Drop the first coefficient. 2 times 1 is 2. Negative 1 plus 2 is negative 1. Sorry, positive 1. So 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. Negative 2. So 1 doesn't work. So let's try negative 1. Okay. So 2, negative 1, 2, negative 1. Drop the first coefficient. 2. 2 times negative 1 is negative 2. Negative 3. Negative 3 times negative 1 is 3. 2 plus 3 is 5. Negative 5. So negative 6. So negative 1 does not work. So let's try 1/2. So I have 2, negative 1, 2, negative 1. Drop the first one. Be 2. 2 times 1/2 is 1. 1 times, or sorry, negative 1 plus 1 is 0. 0 times 1/2 is 0. 0 plus 2 is 2. 2 times 1/2 is 1. So 1/2 works. Okay? 1/2 works. So now, basically we factor out a 1/2. You guys remember this. So this new equation that after we factored out the 1/2 is 2x squared plus 0x plus 2. So we could rewrite this as 2x squared plus 2. Remember, that's the remainder. So now we can factor 2x squared plus 2 and find the rest of the roots. So we can set this equal to 0. Step 1, always find the GCF, which is 2. So we can rewrite this as x squared plus 1 equals 0. So now we can rewrite it as x squared equals negative 1. So x equals the square root plus or minus the square root of negative 1. So x equals plus or minus I. So what are the roots we have? Well, we found the rational root of 1/2 and the imaginary roots of plus or minus I. So we could say it's 1/2 plus or minus I. That gives us 3 answers, and it was a third-degree polynomial. So there we go. So there are the roots. Okay, last example. Find the roots of x cubed plus minus 2x squared minus 5x plus 10. So let's go find the leading coefficients 1, the constants 10. So let's find the roots, or so let's find the possible factors. So plus or minus 1, plus or minus 10, plus or minus 2, plus or minus 5. So let's start with 1. So I got x, the leading coefficients, or the coefficients are 1, negative 2, negative 5, and 10. Drop the first coefficient, 1. 1 times 1 is 1. Negative 2 plus 1 is negative 1. So we can see right here this is not going to work. So 1's no good. So let's try 2. So I got 1, negative 2, negative 5, 10. So drop the first one. 1 times 2 is 2. 2 times 0 is 0. 2, negative 2 plus 2 is 0. 2 times 0 is 0. Negative 5 plus 0 is negative 5. 2 times negative 5 is negative 10, 0. So I have a root of 2.